In this video, I'm going to discuss about groundwater. So, groundwater is a water which is present in the pore spaces of regolith and the bedrocks below the ground surface. That's why we call it as a groundwater. So, main sources of groundwater are rainwater and infiltrating meltwater, which collects in the aquifers. So, aquifers are storage pools of groundwater below the ground surface. So in this image we can see that here this is a confined unconfined aquifer. Why it is called as unconfined aquifer? Because this can move upward, depending, this aquifer can move upward or move downward. So there is no limit for its movement because this zone is a saturated zone. Saturated zone till this is the water table where, so this is a saturated zone. Above this saturated zone, this is called unsaturated zone. Unsaturated zone. And suppose if in unsaturated zone there is a water saturated zone, a small saturated zone, say suppose a clay which has the capacity to hold more water, so that becomes a saturated zone, a small zone. Then we call it as a perched water table. And this is aquitard, which allows a little amount of absorption of water, which this water comes down towards confined aquifer, because just below this layer called aquiclude, these rocks are impermeable. It won't allow the water absorption, or permeability of water becomes less here. The permeability of rocks becomes less, and so this water is confined in this zone. That's why it's called as confined aquifer. Because of this, it's a confined aquifer, the pressure also increases here, depending because of water available, water level is increasing, the pressure also increases. Then it becomes this, when we dig a bore here, this becomes artesian wells. And confined aquifer can move up or move down depending upon the water availability in the ground surface. Now let us understand some of the terminologies in this groundwater. Permeable rocks and sand permeable rocks and sand has a more porosity. Depending upon that porosity, they act as ideal aquifers by allowing percolation of water through its permeable pores. Percolating water fills the pore spaces of regoliths and permeable rocks, and saturation of rocks occurs. So once the water enters the ground surface, because permeable rocks only can allow the water to flow down towards the ground surface. Otherwise, the water will run off, like a surface runoff. So these permeable rocks allows water to enter the ground surface, and those rocks becomes saturated. So saturation occurs. This saturated zone is called as phreatic zone, and the upper level of the saturated zone we call it as a water table. Zone above the water table is called unsaturated zone. Suppose this is a ground surface, this is a water table. So below that aquifer is there. This is a saturated zone. This zone is called saturated zone, but above this water table, this becomes unsaturated zone. This unsaturated zone is called as a Wadaz zone or aeration zone. And alternate beds of permeable and impermeable bed complicates the movement of water. So suppose here permeable rock is there, here impermeable rock is there, and suppose this is a permeable rock, so water can enter, though it can collect. These rocks are impermeable, or so aquitard is there, it complicates the movement of water down and upward. Impermeable bed that separates two aquifers are called aquicludes, and confined water reservoir is produced when the aquifer is jagged between two aquicludes. Then this confined water becomes artesian wells. Accumulation of water in the unsaturated zone above the water table is called perched water table. Suppose this is a saturated zone, this is a saturated zone, this is unsaturated zone, this is the ground surface. Here suppose the saturated zone is there, because suppose clay holds the water here, and this becomes a perched water table. Depth of water table varies with the season. So with the rainy season, suppose if it is a rainy season, the water table will increase. Suppose it is summer season, the water table will decrease. And during rainy season, water table rises, and during drought, water table falls. Geomorphic work of groundwater. So first one is erosional work. Groundwater can do erosional work or a deposition work. Let us see first erosional work. On the surface and below the surface of groundwater, as it percolates down, chemically erodes the soluble rocks. So the chemical erosion is the main erosion which can happen through groundwater. So that is dissolution, the solution, dissolution of rock minerals. The rate of movement of groundwater is slow. That's why the slow erosional work is also very slow, and deposition of solids also occurs because of that. If the rate of movement is slow, then it can easily deposit the eroded materials. The erosional work can be done through solution, abrasion, attrition, and hydraulic action, and groundwater also facilitates debris slides and landslides. But among these, solution is the major form of erosion which can happen through groundwater. The dissolution of rocks like limestones, dolomites, these rocks can be easily dissolved because these minerals, salts which are there in these rocks are easily dissolvable, can be easily dissolved in the water, groundwater. So that's why many landforms, karst landforms are formed because of the groundwater erosion. And depositional work, this is due to dissolution of carbonate rocks, and groundwater becomes more saturated with solute sediments. As the solute sediments increases, the deposition, because the rate of movement of the groundwater is very slow, so deposition occurs, the depositional work is more. The rate of movement is slow, and so erosion and deposition work go together. Since the rate of movement is less, the solution also occurs as well as deposition also occurs at the same time, and larger sediments settle down easily, but finer sediments suspend in solution. These sediments gets deposited due to reduction in water movement, any obstruction or evaporation of water, and if the solution capacity is reduced. Deposition occurs on cave walls and floors, rock joints, etc. So that's how, suppose the water has dissolved the limestone rocks and it forms some sort of cave like structure, then it can deposit the sediments there easily.